that is plotting of a curve. Because if we are not able to plot something, we will not be able to understand whether our algorithm is working or not. Oftentimes, it is clearer to understand visually than to look at bunch of data in data format. So let us spend some time in order to understand how plotting works in Python. So first of all, let us write a string which tells someone who else will be reading this what the purpose of the script is. So in this script, we will begin by a comment. So plotting in Matplotlib in Python happens via Matplotlib. So let us import the module, and simple 2D plots are done using pyplot. Actually, inside Matplotlib, there are a bunch of other plotting options as well, such as histogram, pie charts, and all this. But for this particular exercise, we will import only the pie plot. We don't need to import all the other plots. And let us import it as plt. So plt is the alias of matplotlib.pyplot. Okay. So, and since we will be working with arrays, let us also import numpy. And yeah, let's proceed. So let us define x as np.linspace 0 comma 10, and let's say we have 50 points. So I repeat that x will be an array going from 0 to 10, and it will have 50 points. Let us define y as sin x. So np.sin x. So let us run the program. In fact, let us save it first. Let me save it as okay. So let us run the program. It runs properly. Let us see what x and y are. So x is this array of numbers and y is this array of numbers. So obviously y will be bounded between -1 and 1. Okay, so if someone says, okay, what is the maximum value of y? So the way to do it is vmax equal to np dot amax of y. So let's see what vmax holds. 0.99808, and we know that sine has a maximum value of 1, but in this case it's 0.99808, and the reason being that x is not discretized to a very fine level. But anyway, let us proceed. So let us first make this simple plot. So we say plt dot plot x comma y. So this is the simplest plot that you can imagine. After running the program, we get this plot. Okay, and usually what I like to do is I like to make a specifier. So plt dot rc text use text equals true, and plt dot rc font size equals say 16, just to set parameters. Okay, good. So what do these two lines mean? plt.rc text use text equals true and plt.rc font size equal to 16. So it says that whatever objects will be created by plt, you set whatever text there is inside the plot, and the interpreter for those text should be latex. So latex is a sophisticated environment for writing mathematical equations and all these things, which otherwise you cannot write. So it also makes things look more prettier. It has nothing to do with the mathematics, of course, but okay. And plt.rc font size equal to 16 means whatever objects will be generated by plt, let their font sizes be 16. In fact, we can change it over here. Let's make it 20, and let's see what happens. It has increased a bit. Okay, this was 16 and this was 20. Anyway, let's close everything. So let's replot this. So of course I want to now tell the user what the x-axis and y-axis are. So I will say plt dot x label, and I will give the label within single quotes as x, and I will say plt dot y label within single quotes. So I can write sin x like this. Let's see what the output is. Okay, the outputs are this, but I want to interpret sine not as a simple text but as a mathematical text. So that is why we have used LaTeX. So LaTeX will empower us. So you add a R in front of the string, and you use, instead of sign, you use backslash sign. So backslash sign tells the interpreter that whatever you do, interpret x the sign function as a mathematical function, and you put everything between a dollar sign, because in LaTeX all mathematical symbols are put inside dollar signs. So if you are interested, you can go on the internet, look for LaTeX how to write simple mathematical texts. Just look at this and you will understand what I'm talking about. The R preceding the text is saying that you have to use the raw string, that whatever you are getting. And that is important because oftentimes backslash s could be interpreted as something else. We saw yesterday that backslash t is interpreted as a tab. So backslash s could be interpreted as something else. So we want the interpreter to not interpret this backslash s as something else, but we want to take the whole raw string. So the raw string is outputted by preceding preceding the text by r. So this r is for raw. Okay, so let's run this. Okay, so now it has become a more mathematical form. Let us increase the font size of the labels. So font size equals 20, font size equals 20. Oh, were they already 20? Let us put x inside this dollar as well. Let's make it 24. Okay, so we've got an increment in the size. So let me put a title on this. So plt.title, just plotting some functions. We run the file. Okay, there we have the title as well. But we want to switch on the grid because of course sometimes it is easier for someone to interpret a plot if grid lines exist. So we'll say plt.grid and we will declare it as true. Okay, if you run this, we will see a grid. And what about the label? So we will say plt.label and we will pass a string. So that string will be a raw string between dollar signs sign x. This is legend, not label. Okay. Okay, so there is some error and most likely it is because of this. There is some issue with the mictech that I have installed, but anyway, we can choose not to use LaTeX in this case. Don't worry about it. So it will create an object which is actually going out of the bound, but that's okay. We don't need to worry too much about this. Suppose I want to plot two plots on this. So I will say z equals, suppose I want to plot the Bessel function on top of this. So how do I go about, first of all, importing the Bessel function? So the Bessel function actually lies in the SciPy library. The way to understand where the Bessel function lies is to just make a search on the documentation. So I will import SciPy dot, I've already done it once, so it's special function So special as SP. So Z will be SP dot. So the text format or the function call for Bessel function is JV. So JV is the Bessel's function of, so the JV is the Bessel function of the first kind of order V evaluated at Z. So the order, let it be 1, and let us evaluate for X. So what happens is all the values of X that have been defined from 0 to 10 will be passed to the Bessel function, and it will be stored inside Z. So and Bessel functions do turn up in a lot of applications where cylindrical polar coordinate system is being used. And let us see how it looks. Actually, we are more interested to see how it looks. So let me say comma X comma Z. So to do multiple plots, you just write the X Y pairs one after the other. So X comma Y will be plotted, then X comma Z will also be plotted. So let's run this. Okay, there you go. So the orange line is actually the Bessel function. In fact, let us increase the range of Z. Let us make it go till 20, then plot it again. So the sine function looks a bit jagged now, and the reason is going from x equal to 0 to x equal to 20, we only have 50 points. Let us increase the number of points. Things should look much smoother. Okay, so things look much smoother in this particular plot, and the Bessel function has a property that it starts to decay, at least J1. So this function is called as J1. So we should modify our y level to not just have sine x, but it should also have jx. In fact, let us write only fx over here, and we will say plt dot legend. So the first one is sine of x, and the second is j1 of x. So when I disable my text, everything comes back. I think let me just reset all my variables because there might be something wrong. So reset. Let me use true over here. I think there is something quite bizarre. Well, such things do happen. Yeah, alright. So let us set this to false for now, unfortunately. And it doesn't make a difference. The important thing is we are able to see the plots. Okay. So we have put the legend. So the legend appears here. Let us in fact change the line specifier for the plots. So this line specifier, so plt dot plot will have a line specifier. Let's say it's a black line. So minus k. So there are various line specifiers for various kinds of plots, and you can look up the documentation to understand how you can specify the line style. So minus k stands for a solid line having black color, and let us say this is minus minus or. So minus minus means it's a broken line, it's a dashed line, and it will have the symbols O of red color. Okay, there you go. So this is how we can specify line types. Perfect. So the legend also gets updated appropriately. Now let us say you want to highlight to someone that this is in fact the point where the Bessel function is maximum. You want to say someone that, okay, look, here is the point of maximum value of j. So let us find that out. So z max is equal to np dot a max of z, and but just having the maximum value of z is not enough. We want to know the corresponding value of x at which z max occurs. I hope you get the point. We must also find that corresponding x at which the z peaks. So there is obviously some index of z at which z max occurs. So z max index equal to np dot arg max of z. This output, the function output of argmax, tells me the index of zmax where the maximum occurs. So if I run this file and if I type out zmax index, it says 9. So z9 should give me 0.581, and let us verify with zmax. So look, zmax and z evaluated at 9 are identical. It means the ninth index of z holds the maximum value. So now what will be the x corresponding to the zmax? It will be the ninth index. So x max will be x z max index. It means that whatever the this should be z. So whatever index is returned to me from argmax, I will feed it to x. So x of z max index will be stored in x max. So then I will go here, I will say plt.text. I have to specify the location x max, z max, rather in this case, yeah, z max, and the string. So I will say max of j1x. Okay, so let's run this. Okay, so we have the text appearing near this, but look, the text sort of overlaps with the curve, so we want to offset it. So let us use xmax plus offset and zmax plus offset. Let me define offset as 0.1. 0.1 is a large offset, so let me use 0.05. Yeah, good. So this looks okay. So it tells us, it indicates to us that the value of j is maximum at this point. So this is how you do a simple plot. It is essential to know how this works, and oftentimes many of the algorithms that we implement are much more easily understood using plotting. And we will quickly see this in the next exercise that we will do, and that we will do in the next session.